All right. So you now are capable of solving all types of problems. Again, this is what makes you a very good pre-calculus student. That you're able to solve all problems, all types, square roots, absolute values, all those things, including logs. Okay? So I'm going to give you a few hints because tonight's homework, they're going to give you a ton of different log problems that we've done through this chapter, and you need to know how to solve each one. So the hints that I would say when you look at these log problems are, first ask yourself, can you make it the same base? And even honestly, even on the SATs or ACTs, if you can make anything that has exponents, try to make it same bases, you're going to save yourself a ton of steps, okay? So if you see a 2 and you see an 8 and they're both being to a t power or something like that, try to make them both base 2s. You're going to save yourself a whole bunch of time. Hint number 2, is it a log of, I don't know, we'll call it base x of something equals a number, okay? If it has one log on one side, then you can do this whole thing, like that, okay? If it's got one log on one side, write it as an exponential. Or is it log base c of something equals log base c of something? Does it say log with the same base equal to the same base over here? Or even if it says ln, then what can you do there? Well, there's a property that says you can just set those two things equal to each other. So look for that. Look to see, does it say log equal to a log? Does it say ln of something equal to an ln? Then just set them equal to each other. It's a beautiful thing. Okay. Third hint, can you ln or log, we learned that we could do both, can you ln or log both sides to bring the exponent down? Again, you really only use logs for stuff that you're dealing when you're dealing with exponents and getting the x's out of the exponent. So if you can log both sides and that helps bring the exponent down, then do so. And then final hint that I would suggest on tonight's homework, condense your logs. If you see log plus log equals log plus log, condense them. Make them into one log. Make them into one log. Now, I'm going to throw up 8 problems here. You're just going to look at these 8 problems. You can write them all out. You can leave some space. You can wait until we do each one separately. But then we're going to go over how to do each one. I'll move this up in 1 minute. Okay. So that's what your homework's gonna look tonight. All different problems. And you just have to know how to do each one. Okay? So just looking at this right now, does anybody feel confident enough to say, yeah, I can do that one real quick and easy. That one's pretty simple for me. Anyone right now just jump off the page to you? You tell me.
1.
You okay? 1? That's good. Everybody else in the other class, what are you going to do with 1?
Same base.
You can make them both same base, couldn't I? 4 or 2. Yep. I would make them both 4s. So this would be 4 to the x plus 2, and 16 is 4 squared. So then Once there's the same base, you can just ignore them and set those two equal to each other. So x plus 2 equals 2x minus 6, and then that's easy to solve. What is it, 8? Yeah. That's a great one. Good job. Anything else? 6. 6 is actually really easy. It really is. It's exactly right. The ln next to the e cancels, and that 11 can come in front. It's a power rule, so it's like 11 times 1, which is just 11. Good job, honey. That's exactly right. Okay. See if you can find 2 more that you think are really good and easy to do.
8.
All right. Go, Brian. Tell me what I would do.
Actually, you just combine like the x and the 3.
Right. Okay. I see multiple logs. Whenever you see multiple logs, condense. Okay. So let's make these two combine, like Brian says. When you add 2 logs, you actually rewrite it as 1 log x times 3, or can I rate it as 3x, right? And then once you get this log equal to this log on the same side, let me move this up for everybody. Then I can just set 3x equal to 18. So what does x equal? Done. Double check though to make sure that this is not extraneous. It's not. I mean, if it was -6, we'd say then there's no solution, but this one works. Okay. One more. I'll do one more and then I'll do the rest together. Which one, Liam?
Actually, number
7? All right, let's do 7. What would you do with 7?
make the 1/27th into 1/3 by multiplying the exponents by 3.
Correct. So this is 1/27th, which is actually 3 to the -3. And then 1/3 is 3 to the -1 times x plus 1. But yes, you could make it into a third. I like to rewrite it.
Problem?
Nope, not at all. And so then once you get them to be the same base, -x minus 3 equals -3x plus 6. Just set those two equal to each other, and then you'll get out, is that 9/2? Is it -9/2 or +9/2? Yeah. Yeah, thank you. 9/2. All right, so let's finish the rest of these real quick. I'll help you and talk you through them. It's not that bad, but that was pretty good. See, you know more than you think you know. I think you're just kind of leery to go at the problem, but you should know how to do it. So let me talk about number 2. If I see 1 log when I go into an equation on one side, again, this is what I did from my notes over here. 1 log on one side, do this. So I go like this. Write it exponential. 5 to the 20 equals x to the 4th. And that seems crazy, but it's actually quite doable. How do you undo an x to the 4th? What's the inverse operation there? 4th root it. 4th root it. How do I do a square? I square root it. If I cube root, I cube root it. You could raise it to a power of 1/4. I'm just going to 4th root it. That cancels. I'm left with x equals the 4th root of 5 to the 20th. Again, that index is just the division of that exponent. So what's 20 divided by the 4? So it's really 5 to the 5th. But this is something a lot of people won't remember. Whenever you take a 4th root or a 6th root or a square root, you have to include what in front? Plus or minus. So it's plus or minus 5 to the 5th, whatever 5 to the 5th happens to be. I'm not quite sure. Yes, sir.
Can you put the, where it says x to the 4th in the original problem?
Yes.
Can you bring that to the front and then divide both sides by 4?
You could bring the 4 to the front, divide both sides by 4 would be 5. And yes, that's exactly right. Nicely done. Okay, 3. Okay, these are not the same base. That's a problem. So there's 2 ways to go about this again if they're not the same base. You could, again, do the whole, change this to logarithmic. Right now it's in exponential form, so I can actually make it look like 2. And surprisingly enough, that'll actually help me solve it quicker. Or you could ln both sides or log both sides. It's up to you. You'll get the same answer. I can show you both ways, but I'm tempted to always ln both sides.
Why?
I just always do it that way. And then I don't know why, it's just, I guess that's how I always have done it. But I bring the x in front, so x is equal to ln of 7 over ln 3, which is approximately 1.77. If you hadn't done it that way and you decided to write it in logarithmic form, you would write it as log, and you'd go the whole zoop, you go log base 3 of 7 equals x. Well, guess what? That is the same as that. It's the same as that. They're all the same. So it doesn't really matter however you chose to do 3. But again, whenever they're different bases like that, I just log both sides. That's just what I choose to do. All right, number 4. This is what we learned yesterday. How do you undo an E? You ln it. So if I ln, that's all right, leave it, it's fine. Then I can bring this down, equals ln 8. Then I just get to solving for x, minus 1. By the way, am I allowed to write this as ln 7?
No.
No. ln 8 is completely different from ln 7. And ln 8 minus 1 is not even ln 7. They're not equivalent. So you leave this alone. And then minus 1, you get 2x equals, and then just divide by 2. Divide that whole thing by 2. And that will be approximately, I'll tell you what the answer is, 0.54. Oh, let me go back up to this one that I didn't show you and tell you about. I'm sorry about this. It is plus or minus, but will minus work?
No.
Why won't minus work?
Because
Look at
scale is
Okay, and then last one up here, number 5, is actually like number 8. I see log 2, and I condensed it. Well, ln is just like log, except it's base E. So this would be condensed to be what? ln of x squared minus 3x equals ln 28. Set these two equal to each other. So x squared minus 3x, actually subtract it over and set equal to 0. What two numbers multiply to negative 28 and add to a negative 3?
7, negative 7, 3, 4.
Mm-hmm. And then what would your answers be? 7 or negative 4? Will both of those work? Or one of them work? Or none of them work?
Just 7.
Just 7 works. Because if I put negative 4 right here, it doesn't work. Right, Carson?
Yes.
Okay, now take out this, the back of 3.4 worksheet. It looks like this. Okay? It's on the back side. If you don't have, it was part of your homework quiz, so you should have it. Okay, yeah. You are going to cross off number 4, number 8, 11, and 13. Okay? You do not have to do 20, 21, 23, or 24. Okay? And then you don't have to do 25, but you do need to do 26. Okay? So really, I know it, you're like, well, this looks like a lot. It's not that. There's only, I think, 17 problems total. That's it. 17. Okay? And again, you can look at these right now. Like, look at number 1. What would you do with 5 to the x and 125? What can they both become?
5.
5s. Okay? Number 3, they can both become base 3s. Number 5, I see 1 log, so I do like that. Okay? That's, you've got to get you, when I look at number 2, oh, I see a lot of logs, I'm going to condense. And it gets quite easier. But before I go on, look, there's some of you that need to be prepared for this and some of you who are not going to like this. And that's okay, because you're like, I'm not going to calculus. Should have been in stats.
Yes, that's true.
I want to do number 4 for you. You will not be required to know how to do it on the quiz or test. This is really purely for my people going to calculus. What does this look like to you? It looks like a trinomial quadratic that we're used to factoring. You can factor this, okay? I bet you know which two numbers multiply to -6 and add to the middle coefficient of -1. What two numbers multiply to -6 and add to a -1?
-3 and 2.
But then here's the part in the front that you'll be interested in. How do I get an e to the 2x? What would this and this one have to be? E to the x. Why? Because e to the x times e to the x, you keep the base, you add exponents. X and x make 2x, not x squared. When you add exponents, it makes 2x. So this is e to the x, e to the x. When you set it equal to 0, you actually set each one equal to 0. You'd go like that. Okay. And then if I bring the 3 over, I now have e to the x equals 3. How do you undo an e? You ln it. The answer is ln 3. That's one of the answers. This one over here, I have e to the x equals -2. Again, I would ln it, but then what would happen there? That can't happen. You cannot ln a negative. So your answer is actually ln 3 for that one. Are you going to see that in pre-calc? No, but it is a calculus concept that we do use and we will use. So very fun. All right, so hopefully, again, you can work on this now. Try to make them condensed then, make them the same logs. Get this done now so you don't have too much homework to go through. That'd be great.